Hi there! In this video, ELVA-1 team presents a convenient online tool for calculating, visualizing, and checking the free space in the first Fresnel zone, especially for train-to-ground broadband applications. ELVA's 10G rail system is an all-weather, compact E-band radio link designed for duplex 10 gigabit train-ground communication, specifically tailored for high-speed trains on straight track sections. To open our online calculator, type testcalc.elva-1.com in the address bar of your browser. The main page of the calculation tool appears. Several different tools and scenarios are presented here. Let's take a first look at the 3D Amtrak scenario. Selecting this scenario opens a 3D scene close to Amtrak's Northeast Corridor and a model of the Amtrak Acela locomotive. Please note, if you open this page for the first time, the loading time may be noticeable due to the volume of 3D models being loaded. The download status is displayed at the top center. On subsequent visits to this page, the scene downloading will be faster. This scene draws the ellipsoid of the first Fresnel zone, depending on the parameters selected in the area of the top right. Since the scene shows a 2 km long section between two base stations, the length scale has been reduced by a factor of 10 compared to other directions for better display. You, as the user, can rotate the scene, approach it, or move away with the virtual camera. It is possible to navigate inside objects and along the railway track to control the ellipsoid's interaction with any objects of the railway infrastructure. Additionally, you can change the parameters and repeat the calculation and visualization of the scene. A parameter legend is displayed on the bottom right side to clearly indicate which parameter is responsible for each object in the scene. You can modify the scene by selecting the checkboxes. In this way it is possible to remove poles, third path, legend from the scene. You can display a horizontal and vertical grid for your scene. As you'll notice, I played around a bit with the checkboxes and other scene parameters to see how the scene and models behave. I recommend you also try changing the parameters and see the changes in the visualization. That's all about calculating millimeter wave E-band communications for Amtrak Acela. And next I will show the calculation model for Siemens Velero trains. I will now return to the main screen and select the 3D Velero menu to go to the train-to-ground communication model for Siemens Velero trains. Here is a similar menu and you can do the communication calculations on a straight section of track. Everything is similar to the Amtrak Acela train, but with parameters for Siemens Velero. I won't repeat my story here, you can play with the calculation yourself. The Fresnel zone calculation menu allows you to check that the signal propagation ellipsoid does not touch poles, masts, and other lateral obstacles on a straight section of track up to 2 km long. The distance from the center of the train to the roof radio D1, to the track dimensions D3 and to the side location of the base station D2 can be set here. A few words about other menus. The train log file with circular map allows you to play log files obtained during the real field experiment with this equipment. You can visualize the train on the map and synchronize graphs with the train position. There is also a calculation for a goods train, the same Fresnel zone, only the radio is placed on the side of the car. If you have any questions about the calculations, please contact ELVA-1 team. Thanks for watching.